Welcome to another Tech Tip video. I'm Dan with Carter Agri-Systems, and today we're going to be talking about the needle home sensor on an LB baler.
So we're going to discuss the error codes you're mostly going to see out in the field as you're baling hay. The main errors that I've seen, and currently we have one on the screen, and it's a needle home sensor fault. That is one of 4 or 5 that you will see. The others will be a tie cycle fault, a lower knotter fault, 1 or 2, as well as a continuous cycle error. These errors are caused to multiple situations, but the main cause is a loose or a popped lock collar. And I'd like to show you a few of the tools that are used in this process of adjusting this sensor on the needles. And you'll need a possibly half-inch wrench, a 11/32, and then a hex key of a 1.5 millimeter, and I don't remember for the standard. But then you'll also need a 1/4 inch end wrench, as well as a Phillips drive. As you can see there, I've used a piece of blue towel to hold that in there, and you'll see why. There is a tool from Snap-on that you could get, but this is what I found to work as far as cost effectiveness. This particular tool is the main tool that we're going to be needing, and this is what will help set the gap between our magnet as well as the sensor, and then the relationship between the shaft as well. And that can be found through your dealer, and you could get that through them. I recommend that you have that. As far as bulletins on the adjustments, this is probably the main one that you're going to want to use, and it's a KO 4502953 right there at the top, and the related errors that you'll see. And now we will move to the back of the baler and show you the specific area we want to address. So now we're here back at the back of the baler. This is the right hand side of the baler, direction of travel. And as you look in, this is the area we will be looking into. It is tight, so be aware of that. So on the screen, we showed you how we simulated an error code based off of the needle home sensor. You're going to see that throughout the year, possibly due to a variety of issues. But the main cause that we've noticed is these lock collars right here will pop out or come loose, and then it allows the needle yoke to shift to the right or to the left, which then puts the sensor out of its parameters. And what it's looking for is a 2-volt reference in the home position, and then 4 in the top dead center position of the needles. Generally, the symptom that you're going to see is those 4 error codes as I described, but the main one will be, in worst case scenario, is that you'll get a 20-foot long bale coming out because the needles will not tie. The area that you're going to look for right away is the lock collars, and to adjust the lock collars or the needles would be centering the yoke, locking your lock collars back into position, but then you may run into the issue of not having that voltage reference, and you will still come up with those same errors. And we're going to go through that process of adjusting the sensor. You're going to need the tools as we discussed, and if you're lucky, you'll have a friend or two to help you turn the flywheel to run the needles up. To run the needles up, you just trip the hammer on that left hand side, and you're ready to go. And then just get your friends to turn the baler. So our special tool is what we're going to put in between the sensor and the magnet. So just to show you, this is our sensor, that stainless steel or aluminum looking piece. There is a line on the top of it as far as the orientation. Should be 12 o'clock position. So you'd want to check that as well, make sure that that orientation is correct. But then our sensor needs to be in the correct position for it to get the correct voltage reference. One thing I failed to mention is I like to mark my lock collars with paint pen just so I can quickly see if it's popped. Sometimes this will pop out but will not rotate, so it may be deceiving. So you're going to want to make sure that there's not a huge gap between there. So you grab your tool, you're going to bring it up, and you're going to put it in between your sensor and your magnet there. And that is the correct adjustment. If this arm is too close, you can see here there's a shim pack right there, so you can use it to adjust in or out. But possibly that magnet may need to be adjusted as well. And you can see on our magnet, that's where our Allen or hex key is going to go in, and that's what's going to help you adjust that. But once we get our special tool in, everything gets aligned and flattened in the correct orientation. And at that point, you can then begin the tightening of your hardware. This is where that special tool, well, our makeshift tool, improvised tool, will come in, because you can see how tight that is. And a lot of times you'll have to come in there and get pretty snug with it. If you're lucky, you can come in here and just tighten that without turning your hardware. So I'm currently going to bring the bracket down and get it in a sweet spot to where it can stay stationary. And then from that point, if there's an issue with the relationship between my sensor and my tool, the sensor, there's slots in here in this bracket, so the sensor can be adjusted up and down. Be aware that it's not a whole lot of play, but you can do some adjustment through the sensor. Just loosen your carriage bolts. Not so much to where your tool will fall, but enough to where you can bump it up if you need. And at that point, you can see where our shaft is resting on our tool, as well as the bracket for the sensor, and that'll get you close for your final adjustments. And then just snug it down. And we'll go through the voltages that we want to see on the monitor to assure that we're in our correct parameters. We're back at our screen and we're going to check our adjustments. We're going to assure that we're within parameters. And in order to do that, we're going to come into our tool icon. We'll have our meter icon there, and that's where we want to go to check our parameters. So as you can see here, this is our needle home voltage reference information, and currently we're at 2.5, so we're within parameter, and that's in the home position. So the next thing we're going to do is trip our knotter, run the needles to top dead center, and we want to be within 4 volts and 4.5 volts. And if we're there, then we can take the baler out to the field, test it in field conditions to see if there's anything that may cause us to have the error reoccur due to bouncy conditions or the plunger moving, those type of situations. And if it does throw an error, you may need to come back to the screen, check your voltage to see which side you're having the error on. Where I'm going to be tripping this manually on the baler is right here off of this hammer. And you just grab a pry bar or your foot, whatever is accessible to you, when it's not running. If it's running, I usually use a pry bar, and I'll put my pry bar right there and just knock it over. But that's all you want, is that hammer to drop, so that when it catches the lobe, it'll cycle. So I'm going to have my partner run the baler to kind of give you a reference on what to look for as it's running, but also to show you when you know it's in top dead center on the needles. Okay, Dan? So here you're going to see how it was engaged. Our roller is now going to engage the lobe on our cam or our sprocket. It's now going to go through its cycle of tying. And as you notice, the drive arm is going to come up. Okay, Dan, just a little bit, bump it. Keep going. A little bit more. A little bit more. Right there. So what we're looking for is to have our drive arm be in line with this bolt here, and that puts you at top dead center. And at that point, you're going to want to go back to your screen and look at your voltage to see if it's within the parameters that the machine is looking for. So just as a recap, what we're trying to accomplish is to assure that our sensor and our magnet are having a correct relationship. On the tighter side, I have found that it will find that voltage that it needs. It's usually on the gap that we have the issue of those multiple error codes. And those multiple error codes will vary depending on the orientation of the yoke and how it pulls the sensor away from the magnet. So what we're going to do here is we're going to look at the voltage references that the controller is looking for and also showing us, and see what it's at. As I stated before, that voltage will change. We're simulating it here, and it'll give us a pretty clean voltage, but as you're going through the field, it will bounce around a little bit. So you want to test your work running a few bales through it before you just call it good. So we're going to show you here that it's going to go up, and then it's going to come back down after it hits top dead center. So as the needles go up, you see that voltage climb, and you want to be closer to 4 volts. But here we see that it got to 3.58, and now it's coming back down to that 2.5 as it comes to the home position. So it's not ideal voltage, but you're still going to want to test it in the field to see if it likes it. And if it does like it, you can move on and bale up your hay. If it doesn't like it, then you're going to go back and readjust your sensor to where you do get closer to that 4 volt range. When you have your tool in there for the adjustment, it will be on the tight side. The preference is to be on the tighter side. A lot of your issues do come from it when it pulls away from your sensor pulls away from the magnet. So ideally, you're safer on the tighter side. So we're gonna look at our components again while they sit outside of the baler. Here's our magnet, and as you look at it, it has 3 set screws in it with that 1.5 hex key that goes into them. And then there's our line that needs to be in the 12 o'clock position. Here's our sensor. As you can see, it has the slots in it for the adjustments of it going up and down. There's no adjustment for it to be moved away from the magnet, aside from the shims that are on the baler mount itself. So as we go to our tool here, our sensor is going to rest on the back of our tool, and then you can see here where our shaft is going to lay, and that's going to rest up against the shaft, and then our magnet is going to be set right into that position when it gets put up into that, between the magnet and the sensor. And then you can see here, that's our 2mm gap that we're looking for when it comes to the relationship of the magnet and the sensor.